Viewers, welcome back to our online class. Today we have another interesting question, but this time it's on trigonometry. A question that looks very small, but the procedures to get the answer is a bit blunt. And if we look at this question very well, nothing much is given to us, hence we have to be very creative. If I decide to label this question, or rather this equation number one, that will help us. Now 1.5 is equivalent to 3 over 2 as a fraction. So the next option that can get us into something that can help solve the problem is to square both sides. Square both sides of equation 1. If we do that, it means we have tan x plus sec x all squared equal to 3 on 2 all squared. This very both step is actually 1 mark. It is an external exam. Now, in trying to do this squaring, we have to multiply tan x plus sec x twice. So we have tan x plus sec x, tan x plus sec x equals 9 divided by 4. What do we do again? We need to distribute these guys. So if we use tan x to distribute these brackets, we are going to be having tan squared x, tan x to multiply sec x, that will give us tan x sec x. Now, if we use sec x to multiply tan x, it gives us again tan x sec x to maintain the order. And because of space, sec x multiplied sec x will give us sec squared x, everything equal to 9 all over 4. So if you look at the expression here, tan x sec x plus tan x sec x is the same thing as xy plus xy, which is 2xy. So we can write the third step as tan square x plus 2 tan x sec x plus sec squared x equals 9 all over 4. Now at this level, we have to go back to our fundamental basic trigonometric identities, of which one of them says that 1 plus tan squared x is equal to sec squared x. If you ever take a course or took a course in algebra in SS1, you should be used to this. So if we do this, in place of sec squared x, we will impute 1 plus tan squared x. That will help us get to our destination. And when we do that, we can write the equation as tan squared x plus 2 tan x sec x plus, in place of sec squared x, like I said, we will impute tan squared x plus 1 equals 9 all over 4. So at this level, we can collect like terms again. We have tan squared x plus tan squared x. It's more like saying s squared plus s squared, which is 2s squared. So that will give us 2 tan squared x plus 2 tan x sec x equal to, this number 1 we carry to go and meet his brother, 4. And that becomes a minus 9 over 4 minus 1 all over 1. Now at this level, we are almost done, because we cannot factorize. But before then, We have a small fraction here. I don't think there's any problem with that. So 9 over 4 minus 1 over 1, LCM is 4. 4 divided 4, that's 1. 1 multiply 9, 9. 1 divided 4 is 4. 4 multiply 1, that's 4. So I can write 2 times squared x plus 2 times s sec s equals 5 all over 4. Now at this level, we have watered the problem down to a level where we can factorize. If you look at the terms here, this is tan square x, which means tan x multiplied tan x. The second guy here, 2 tan s sec x. We can see that tan s is common to both of them. And not just only tan x, 2 tan x. So if I factor out 2 tan x, I'm going to be left out with tan x plus sec x equals 5 on 4. This question came from nowhere, but very strange place. And it took us some time to figure it out. Now, if you look at this critically, and look at equation number 1, that will be the solution to this problem. Tan x plus sec x is actually equal to 3 over 2, or 1.5. So in place of tan x plus sec x, we are going to impute 3 over 2. So this will give us 2 tan x multiplied by 3 all over 2 equal to 5 all over 4. So at this level, we will do a basic arithmetic operation of multiplication and division. Now, we have 2 tan x okay, before we even do that, before we go up, 2 can cancel out 2. 3 multiplied by tan x should give us 3 tan x. On the right side, we have 5 over 4. We divide both sides by 3, which is the same thing as multiplying both sides by the inverse of 3, which is 1 over 3. We are going to have tan x equal to 5 all over 4 times 1 all over 3. Tan x will now be 5 all over 12. One of the most interesting questions we have solved since we began this project. Like I said, the mandate is to make mathematics simpler again. Now, if you look at this place, all you can remember if you have taken a course in geometry is look at one. This is all you can remember here. So basic trigonometric function is going to come in. Question came from a very bright student in our science tutorial, body point tutorial. Now, from basic trigonometric function, we know tan is opposite over adjacent. So I will draw a right triangle. I'll put the angle here, x. And if you can recall very well, tangent is opposite over adjacent. Now we have the tan of x equals 5 over 12. And 5 is the opposite there. Then the adjacent is 12. Because the side facing the given angle is the opposite side. So if I label this triangle A, B, and C, so we need to calculate AC, which is the hypotenuse. So using Pythagoras' theorem, we can see that AC is the square root of 5 squared plus 12 squared. That will be the square root of 25 plus 144, which is the square root of 169, and that should give us 13. Very interesting question indeed. The most interesting we have dealt with so far. So I write 13 here. Now, the right angle triangle is very fundamental in trigonometry because it can help us define the three basic trig ratio. Now we have tan x equals 5/12. From this triangle, I will say sin x is equals from the acronym here. So sin means opposite over hypotenuse. That will be 5 divided by 13. I'll do the same for cosine. The term you see here is cosine equals adjacent over hypotenuse. So cos x equals 12 all over 13. Viewers, we are done. What is left is a function of what we call the inverse trig ratio. Now, we are asked to find, this is the end point of this problem, cosec x plus the cotangent of x. From inverse trigonometric ratio, we know that cosec x is 1 all over sin x. And we also know very well that the cotangent of x is 1 all over the tangent of x. This being said, we are gliding towards the final answer. Now, sin x here is 5 over 13. If I take the inverse of 5 over 13, and tan x is 5 over 12. If I take the inverse, that becomes 1 all over 5 all over what? 13. Okay, 12. 12, sorry. Tangent is 5 all over 12. 5 over 12. Now, at the end of the day, I hope not to do this, but for those of you who are following us, if I say just, okay, the inverse 13 over 5, you may not understand. So if you take the inverse of a fraction, the fraction will reciprocate. So that becomes 13 all over 5 plus 12 all over 5. Now, the two denominators are the same. What do? We retain one of them and add the both numerators. This will give us 25 all over 5, which is 5. As a matter of fact, it's the nicest questions we saw so far. I want to appreciate you for watching, liking, and sharing this video. Continue to do so that you can be encouraged and more motivated to do more. Thanks and God bless.